All right, the next section in our book is patterns and sequences, and it deals with arithmetic and geometric sequences. Now, these are the formulas. I'm going to go through these with you, explain, remind you, refresh you, okay? So breathe in, breathe out. Okay, here we go. So arithmetic sequence is just a sequence of numbers where we're adding the same number every time. So let's say I have, for example, 2, 4, 6. What's my next number going to be? Well, I'm adding 2 each time, so the next number is going to be 8, right? All right, so that's an arithmetic sequence. Now, they get more complicated because they like to throw fractions at you, or they're subtracting the same number every time, which is adding a negative, okay? So sometimes it might be not as obvious, okay? 2, 4, 6, 8, pretty obvious, okay? Let's do, I'm trying to think of something crazy. 27, and then, let's see, 26.125. So and then 0.875 gives me 25.25 and so on. Now, anytime if you know for sure it's arithmetic sequence and you want to know what's going on, all you have to do is take the second number and subtract the first number. So 4 minus 2 is 2, so I'm adding 2 every time, right? Then I'd take 26.125 minus 27. I would get negative 0.875. So I know I'm subtracting 0.875 every time. Does that make sense? So on arithmetic sequence, if it looks kind of crazy, take the second number minus the first number and it'll tell you what you're adding. Okay, in this case we are adding 2. In this case we're adding negative 0.875. Okay, so that's a little shortcut to figure it out. Okay. All right, so now let's look at this formula that we have up here. I know you've seen it before, and well, you should have anyway. Let me know if you need to kind of go over this and over this a few times. I get it. Okay, so when I'm looking at this formula is specific to finding a certain term. So let's say I have 4, 8, 12, so on, okay? And they want to know the 100th term. Okay, now I don't know about you, but I can tell this sequence I'm adding 4, right? But I don't want to sit there in my calculator and keep adding 4 till I get to the 100th term. That's when this formula comes in real handy, okay? So what we have to do, A sub n, that just means, hey, what term am I looking for? I'm looking for the 100th term, so n becomes 100, okay? So n is 100, so I'd say A sub 100. I cannot write when I'm recording for some reason. Okay, so A sub 100. So now n equals 100, because that's the term I'm looking for, the number I'm looking for, the 100th term, okay? Now, A sub 1 just means, what's my first term? Okay, in this case, my first term is 4. So I'm going to put 4 there. Plus n minus 1. Well, what did I say n was? 100. So 100 minus 1. Now D, this word right here stands for common difference. Okay, now remember earlier I said to figure out what they're adding each time, you take the second term minus the first term, right? So that would tell me what the difference is. In this case, D would be 4, because I'm adding 4 each time, because 4 plus 4 is 8, 8 plus 4 is 12, and so on. So I'm going to put 4 here at the end. Do not put plus 4, okay? This means I'm multiplying those, okay? So that's the same as 4 plus 99 times 4. So in other words, I'm taking my original number 4 and I'm adding 4 99 times. Okay? That's the quicker way than sitting there doing it in your calculator over and over and adding. Okay? So over to your calculator, 4 plus 99 times 4, and you would get 400. Okay? So my 100th term is 400. Okay, does that make sense? That's arithmetic. Use your formula. A sub n is the term you're looking for. A sub 1 is your first term. And D is your common difference. Okay? Everybody good on that? All right. Well, let's jump over to geometric real quick. I'm going to try to do this all in one video. All right, geometric. Geometric is when you're multiplying by something every time. Now we can start off with something basic. 3, 9, 27. Okay, we're multiplying by 3 every time. Okay, we can see that. It's very obvious. Now sometimes it's not so obvious. Okay, so let's say I have 30, and then 10, and then 10 over 3, etc., etc. Now, most of you would say, well, Ms. Miller, that looks more like maybe an arithmetic because I'm going down. I must be subtracting something every time. Well, remember, on a geometric, I can multiply by a whole number or a fraction, okay? So anytime when you're looking at these and it's a geometric sequence, take the second number and divide by the first number. So 10 divided by 30 gives me 1/3. So I know I'm multiplying by 1/3 every time, okay? So 30 divided by, or times 1/3 is 10, and 10 times 1/3 is 10 over 3, and so on, okay? So you see how that goes. Now, let's say I'm just going to use the 3, 9, 27, okay? All right, so here's my sequence, and they want to know the 18th term. Because multiplying, you can get really big really fast. That's why I didn't do like a 100th term like I did on arithmetic. So if I'm looking at this 18th term, 18, it's just like the other one. This n is going to become whatever term I'm looking for. N is the term I'm looking for. Okay, so that'd be G sub 18. That just means 18th term. Okay, G sub 1 is my first term, just like before, right? First term, so in this case is 3, times R. That's your common ratio. Okay, because remember I said you could multiply by a whole number or a fraction, and whole numbers can be represented as fractions. So fractions are ratios, right? That's why I call it common ratio. So in this one, I'm multiplying by 3 every time, so now R is 3. Okay, and then to the n minus 1, well, if I'm looking for the 18th term, 18 minus 1 is 17, right? So then I'm going to put that in my calculator. You're only putting the right-hand side in. Don't put that, okay? That's kind of like your x equals, okay? X equals, so we're going to say G of 18 equals 3. Now, don't say 3 times 3, get an answer, and then raise it to the 17th, okay? You're going to say 3 times 3 raised to the 17th. Let the calculator do the math for you. And it's a big number, 387420489. Okay? Makes sense. All right, I'll be posting another video in a minute on summation.